focus on the strategy of solving this kind of question, plane stress analysis. So if you look at a question, normally you will see question like you are given y and x direction or axis, and then you will be given the coordinate of 3 points. Okay, so you have I, J, and M. So each one labeled as I means the first point, second point, and third point for M. And then each point give you one coordinate system, 0, -1, 2, 0, and the third point 0, 1. So this is Cartesian plane. And you always compare with the diagram that I showed you this morning. This one, the 0, this one is xi. This one, -1 is yi. All right. So this one 2 is this one is z xj. This one is yj. This one is the third point for m, xm, and ym. Okay. All right. Now the question. This is a tutorial question again. Everything will be given, but when it comes to exam, you need to read further. You are given more information in Finite exam. So you need to evaluate the stiffness matrix. You need to find the K for the element below. The coordinate shown in the unit of meter. Okay. Assume plane stress condition, meaning you need to use the plane stress equation or equation from chapter 6. Modulus Young or elasticity constant is given, E equal to this one. Portion ratio given 0.25. This is to calculate the capital D matrix. Thickness given, T given. So assume element nodal displacement have been found. So meaning you're given the U1, V1, U2, V2, V3, U3, and V3. So all these numbers are given. Then you determine the stresses inside the element. Okay, so how do we solve? Try to observe the steps. So what equation we use for chapter 6 question? First, call out the equation for K matrix. K equal to T A B T D B. So this one I ask all of you about how you derive this one, and all of you know how to find the KII and so on. So to evaluate that one, we need to obtain what is your B. So again, recall these slides, how to find the alpha, gamma, beta, and so on. So alpha, beta, gamma given by this 9 equation. Alpha 1, alpha 2, and so on. Okay. So this one you can come back to this slide later on. What important now is that you know the strategy to solve it. Okay. So you calculate what is your alpha I equal to xj ym minus yj xm. So if you look at the diagram and below, you know that your xj is your point j x coordinate, which is 2. Ym is point m y direction, which is 1. So this is 2, this is 1. So 2 times 1 you get 2. And then the yj is j point, y coordinate 0, xm, m coordinate x direction, it is 0. So 0 times 0 means 0. And so on. So you calculate the alpha I, alpha j, alpha m according to the this equation. You calculate bj, bm, and so on. calculate these 9 numbers. So normally when it comes to final exam, you have 9 equations. This 9 equation give you 3 marks if you're able to calculate correctly. So each one half point. So you get 3 marks for all these 9 numbers here. Okay. All right. So at the moment, we don't need to find the alpha. After you find this number, you focus on beta and gamma value for the beta. Okay, for the beta. Okay, why? Because your B matrix is only involved. Let me find you the beta matrix. So you can see on the screen here, the beta matrix consists of beta and gamma, beta I and gamma I and so on. So there's no alpha needed for the B matrix. But in exam, please find the alpha. Please find the alpha for the sake of to show you understand what is alpha meaning. So I show you the first one just to test you understand. So beta I equal to yj minus ym. So what is yj mean? Means j point y coordinate, jy coordinate 0. Ym, what does it mean? It means point m y coordinate 1. So 0 minus 1 equal minus 1. Okay, just to check. Chia, can you do the second one? What is beta j equal?
1 minus
Y minus
1, so 1 plus 1, 2.
2. Okay. So ym 1. So ym 1. Yi is yi means I point. Y coordinate minus 1. So remember to carry your sign. So 1 minus minus means 2. Okay, test one more. Sue, can you do beta m?
-1. Wait, no.
Yeah, correct.
Yes. Yeah, -1 minus 0.
Minus 0. Okay, so equal to?
-1.
Okay, correct. And then the rest you test yourself. I will just give you the answer. Yes.
I don't understand that part.
You don't understand what is this?
Yes, that part.
Okay. You don't understand what is yj, what is ym. It's a coordinate system, Brian. It's a coordinate system.
Okay.
Do you understand this diagram?
Yes.
So back to tutorial question. What is yj? What is j mean to you, Brian? Yj means you refer to point number j. Y coordinate.
Yj.
So what is the value for yj? Referring to this
0.
diagram. 0. So 0 minus, this is ym. So point m, y coordinate.
1.
1. So 0 minus 1, you get minus 1. This is just substitution of coordinate. And so on.
Yeah.
You do the same for Gamma focus on X. So for example, XM, what mean by XM? It means focus on point M, X direction. Where is your point M? This one. X direction. One is X, one is Y. So this is your XM. 0 minus XJ, focus on point J. X direction, 2. So 0 minus 2, you get minus 2. Do you get it now, Brian?
I get it now.
All right. Ashma, you able to follow, right?
Yes, sir.
Okay. Ashma, what is the value for gamma J?
0 minus 0.
So 0, huh? Okay, good. This one you double check yourself, huh? Okay, once we get your beta and gamma value, you put into a matrix form, all right? Beta and gamma. So you need to calculate beta and gamma, and then I show you one slides on the beta value. So you calculate the beta and gamma already. You substitute inside here, and then you do the, and then you put you put into the beta form. Okay, you put in beta form because beta equal to 3 matrix, and you just need to substitute the value that you calculate inside these 3 matrix, and then you rewrite in the matrix form. You will score point for B matrix. B matrix, just a side note, is also called gradient matrix. But anyway, what is important for you is that these 3 equation, right? Just substitute the value. So your beta will equal to this form. Okay, after you combine the 3 matrix, these 3 matrix. Okay, so as you can see from these slides, your beta, this one, equal to this whole thing. Okay, this is your D. Okay, so this is your B matrix. So refer to the slides, and then you just substitute the value that you find. What is your beta? What is your beta J, beta M? So I think this one more straightforward lah. Okay, after you find your beta and gamma value, you just use these slides. Beta equal to 1 over 2a, and then you copy all the value here, and then you substitute the value that you find. Okay, back to our tutorial. So I show you beta equal to 1 over 2a and the beta gamma matrix, and the value that we find just now, I put on the right hand side. So you just substitute lah, for example, and then you substitute the value as you see on the screen here. Okay, now once you find your beta, then what you need to recall, this is slides is to find the inverse lah. Okay, how to find the area. The next one is to find the area A. Once you find your B, you can do these 2 already, and then the next one is find A. A, you use this equation. Okay, you have your x coordinate for I point. You have the coordinate for J, Y coordinate. This is the coordinate for M, and so on. You substitute the value, divided by 2, you get A. So I'm showing you. I'm copy the equation. Basically, this will score you 1 point for in the exam. Just give me the equation, you will score 1 point, and then you substitute all the equation. So the area you will get 2 meter square. All right. So this is a tutorial question. It's very straightforward. So when it comes to final exam, you will get a irregular shape of rectangular. So you need to use this equation to find the area. So you get the B, you get the A at this point, thickness given. What about D? D. So what else? Okay, this will just substitute the A value that you find just now. This is 2, or from the diagram, you know how to find the area of a normal rectangular, right? Base times height divided by 2. So base, what is the length here? So you have 1 and minus 1. So you have 2. The height from here to here is 2. So base times height divided by 2, you get 2. Okay, this is the area of a rectangular. If you have a normal rectangular, but you have an irregular shape, then you need to use this equation. Huh? Okay. Next, the D, you just use the D equation. Position ratio is given, modulus Young is given. You're able to find what is your T. Okay, so this just give you what is the T derivation slides. Okay, so you just substitute the value, E given, Poisson ratio given, and you use your calculator to calculate the number. So basically you have the T, you have the A, you have the B, you have the D now. The rest is just use the online tools to help you to calculate. All right. So I'll just show you. So you have these 3. So in exam, you need to write this equation. You need to show me how to, what is all this value. For example, you need to show me the equation. You need to substitute the value for me in the exam. You need to do the transpose in your answer, meaning you write the transpose of B matrix. Okay, B transpose. And I think I forget to bring the half. Okay, no, this one 1/4. I forget to bring 1/4 here. So okay, my mistake. But you get the idea. D and B and so on. So if I put everything in one whole calculation steps, all right, one whole calculation steps. So this one will score you some point, this one will score you some point. All right. Then you use the online calculator to help you to do the multiplication of 3 matrices here. Okay. All right. So at the end, you will get a constant times 6 times that matrix. So I will leave you as your homework. But basically what is important, you understand the procedure. All right. So after you get the K matrix, after you get the K matrix, so you get a constant value 6 times that matrix. Again, what is the numbering of your K here? You have 3 points. UI, VJ, UI, VI, UJ, VJ, VM, UM and VM. Same with the side here, and then later when you solve the question, you need to park the number correctly. All right. Yeah. Just take note, the numbering always anti-clockwise, from I to J, I to M, I, J, M. Always park your number in this sequence. Right. The exam will confuse you a little bit. Maybe I will just label this one as 1, and then I change this number to 3. This one is 2. But when you do numbering, you need to park the number correctly. All right. So I will put that in the tutorial question also, so that you can see how we solve it. So the next one, we need to solve for the stress for the element. So we use this equation. Stress equal to D strain. Stress, you have X, Y, and XY. Shear stress. And then on the right hand side, you have also XY and XY. D, we already show you how to find the D. All right. So you can write in this form. So you can, this one equal to BD, right? B we already found. D we already find. Displacement was given in a question. U1 until V3 was given. So basically, you just substitute the value for the matrix. So in exam, you need to show these calculation steps, so that we understand what is happening in your calculation. So how you substitute the number in the displacement? The first one is U1, second one U1, V1, or I, all right? This is a, okay, UI, VI, UJ, VJ, UM, VM. Remember, our calculation is I, J, and M. So in our case, the first triangular that we have, sorry, not this one. Our triangular, we have two sides. We have two sides, but we are looking as a one whole triangular already. Later, we have one example that we break into two. So this one we combine into one triangular. So you just substitute the value given. So U1 until V3, you substitute inside here. Then the rest is just multiplication. So you get your value of your X direction stress, Y direction stress, and the shear stress. Okay, and then you need to put them into principal stress. Okay, after you get shear X direction, Y direction, and stress in X direction, stress in Y direction, and shear stress at XY, these three numbers enable you to find the principal stress, which is this one, stress 1 and stress 2, and then also find the angle, principal angle, right, which is your theta 1. Okay. So what are the equations? So recall what you learned in static dynamics. Stress 1 equal to, or principal 1 equal to shear X plus stress X plus stress Y, and so on, plus square root of this equation. And then the second principal stress, you use the negative compared to the first one. You get the minimum, maximum, and minimum. So sometimes we will not, you will not see principal stress in the question. You will see what is the maximum and minimum stress in the system. Also same meaning of the principal stress. So, and then the principal angle, tangent to theta equal to this equation. So the rest is substitution. All right, you have your all these value, you just substitute, you get the value. Okay. Let's go a little bit more deeper. Oh, let me see here. Maybe we stop it here and then we continue this Thursday. Is that okay? Or you guys can still go on?
Okay, sir.
You okay means what? You can go on or stop.
Stop.
Okay. What about the rest? Okay, let me stop the recording first.